We're going to name now other compounds containing cyclic structure, but this time a little bit more complex. So let's get to it. First, I want to remember our convention for wedges and dashes. So when we have methane, remember that when we draw the Vesper structure, and we say that the 4 hydrogens in methane, so methane is CH4, remember that. So the 4 hydrogens are in the corner of a tetrahedron structure. And our convention is that the wedges means that this carbon is pointing away, so pointing towards me, out of this plane. This plane here, so it's pointing towards me. That's a wedge. The dash means it's going in, so away from my view. So that's the convention, and we're going to keep that in mind because we're going to name now this compounds that is cyclic. Another thing that we want to remember is that when we have a structure like that, we know it's a cyclic structure, and we add a word, a prefix, and we say cyclo, then we count the number of carbons, and that's cyclopentane. So with those 2 elements, now we're going to build on other type of structures, which are called bicyclic. So now, let's say that I have this, and now I am going to draw this little wedge here. And remember that what that means is this is coming towards me, right? The wedge is away from the plane. And the other atoms I drew in the cycle. Now this type of structure is called a bicyclic. So we're going, when we're naming it, we're gonna say first a word like we added here, but this time we're gonna say bicyclo. And then we're going to put something in the brackets. We're going to say in a minute what's that. This is to say how this system is connected. Then in the part here for the parent name, notice that here I have, this is for the number of carbons is 5 in the termination for alkane. So same here. I'm going to count all the carbons here. And I have 1, 2, 3, 4, 5, 6, and 7 with this carbon in the top. So it is hept for 7, heptane. So bicyclo, something there that we're going to use to specify the connectivity, how this is connected. So, all right. Another thing that we need to define to establish what's in here is a name for these carbons that are connecting the rings. In these atoms are in the boxes are bridgeheads. And now what we're looking at is what is to one side or that. So my 2 bridgehead, what is to that side? How many atoms are to the other side and on the top? And then I'm going to list those here. So here I have 2 atoms, so counting from the bridgehead, I count 1, 2. So I'm going to write here a number 2. I'm going to say bicyclo 2, and then I'm going to put a period. And then on the other side, I count. This is a bridge. This is a bridge. I count 1, 2. So I'm going to put another 2. And then again, focusing on my bridgehead, this 2, I have 1 atom. So the name of this compound is bicyclo 2,2,1 heptane. Now we're going to modify that structure a little bit. And also I'm going to give you another drawing that we use for that. There is a perspective type of drawing. Notice that I have this structure with 6. In this, I can draw in perspective the following way. This is the 6 carbons, so 1, 2, 3, 4, 5, 6. And now this that was coming, say, towards me, the wedge, what I'm going to do is I'm going to do this line. So I'm going to, this didn't seem so pretty. But anyways, it's now up. So it is, instead of I'm viewing it this way, now I'm like holding it by here, and this is it. So that's carbon 7. And another thing that is, that we're gonna note, then again, our bridgehead, same thing we did before, are this. So just doing a different drawing of the same. So then we count from the bridgehead, so this box is 1, 2, and on the other side, 1, 2, that's the other 2, and here in the top, there's 1. So we're gonna do more of that, more problems, do naming bicyclic structures.